It starts as a simple journey. You board the aircraft, settle into your seat, and hear the captain announce the cruising altitude, and your mind wanders. Somewhere between the gentle hum of engines and the aroma of coffee wafting through the cabin, a question crosses your mind. How does this airline make this work, economically speaking? It's an important question, and at the heart of the answer is a key metric in any airline's financial strategy: RASK, or revenue per available seat kilometer. This single figure encapsulates how well an airline converts its capacity into revenue. Often called unit revenue, it's calculated as total revenue divided by available seat kilometers, or ASKs. Every dollar you spent to board this flight counted as a dollar of revenue for the airline, from ticket prices to in-flight snacks. And it all feeds into this equation. Breaking it down, the two components are revenue. This is every dollar the airline earns, including ticket sales, fees for checked baggage, in-flight purchases, and even cargo revenue from the aircraft's belly. And available seat kilometers, or ASKs. This measures capacity, calculated as the number of available seats multiplied by the distance flown. Even empty seats contribute to this metric, making it a key measure of efficiency. To take an example, Southwest Airlines RASK in the third quarter of 2023 was 12 cents. Good to know, but in isolation, a RASK number isn't particularly useful. But it is when used to compare the unit revenue performance between particular time periods or between competitors, and it's something that executives monitor very carefully. Consider this example of RASK for Delta Airlines over 2 years. Note that in North America, the convention is to use RASM, as miles are used rather than kilometers, but the concept is the same. Note how unit revenue fluctuates depending on the season, in line with passenger demand. There are clear peaks during the summer in Q3, and lulls in winter in Q1. Knowing and understanding RASK is important, as revenue trends are of interest to airline executives and investors alike. It highlights performance differences between routes, regions, airlines, or historic periods, and can mark expectations for future performance too, in the form of forecasts. While the formula is straightforward, the strategies airlines employ to optimize RASK are anything but simple. When you booked your flight, you probably noticed prices varying wildly depending on the time, route, and even day of purchase. This isn't random. Airlines use sophisticated revenue management systems to dynamically adjust fares. Early in the booking window, prices are lower to encourage early reservations and gauge demand. As departure nears, prices fluctuate based on remaining seat availability and demand projections. The goal is clear: to fill as many seats as possible at the highest sustainable revenue. As we saw earlier, some airlines do this better than others. But busy flights aren't enough. Empty seats still contribute to ASK, reducing RASK. This is where airlines adopt tailored strategies. Low-cost carriers, for instance, prioritize high load factors, ensuring almost every seat is sold. They do this by offering stripped-down services and charging for add-ons like checked bags, seat selection, and priority boarding. By contrast, premium carriers focus on offering a superior product, commanding higher ticket prices while accepting slightly lower load factors. Even after you've paid for your ticket, the airline continues to monetize your journey. Every ancillary charge, from the coffee you sip mid-flight to the Wi-Fi you log into, feeds into the revenue side of the RASK equation. For low-cost airlines, ancillary revenue can account for as much as 40% of total income. In the low-cost model, the ticket price is only part of the financial story. The extras drive significant profitability. Aircraft efficiency plays another critical role in determining RASK. Modern airplanes like the Boeing 787 or Airbus A350 are designed to maximize ASKs while minimizing operational costs. These fuel-efficient planes allow airlines to carry more passengers over greater distances with less fuel. Even the cabin layout is optimized for RASK, with slimline seats and high-density configurations helping to fit more passengers without significantly increasing costs. But RASK doesn't work in isolation. It must always outpace its counterpart, Cask, cost per available seat kilometer, which includes all operating expenses, fuel, maintenance, crew salaries, airport fees, and more. When RASK exceeds Cask, an airline is in the green. If it doesn't, the airline may need to cut routes, adjust fares, or innovate to reduce costs. The 2020 pandemic underscored the delicate balance between RASK and Cask. With demand plummeting, airlines faced half-empty planes, causing RASK to drop dramatically. To survive, carriers had to rethink their operations, from parking aircraft to reduce ASKs, to focusing on cargo revenue to help make up the revenue difference. As your flight descends and the cabin prepares for landing, it becomes clear how interconnected every aspect of the airline's operation is with RASK. From the speed at which you and your fellow passengers disembark so the aircraft can take off somewhere again, to the loyalty programs enticing you to rebook, every touchpoint reflects an effort to optimize this crucial metric. While passengers may never see RASK on their tickets, it governs the health of every airline. It's the measure that ensures airlines stay afloat, balancing costs and revenues while competing to deliver value. Next time you board a plane, consider how much thought and strategy have gone into ensuring that every kilometre of your journey remains sustainable, efficient, and profitable. RASK is more than a number. It's the invisible framework keeping the aviation industry in the air. If you liked this video, you'll like this one too. And don't forget to like, share, and subscribe.